My name is Dave Benham. I am a product manager on the Cisco Wireless team, and I'm going to talk some highlights of some really cool things we've been doing lately. Then Min-Se Kim will come up and dive into some even cooler things in the second half of the presentation. So we're going to talk about some new APs. We're going to talk about some test results that my friend Jim Florwick and I did in our RF lab, and AnyLocate, which is our AP auto location umbrella term, and then ultra reliable wireless backhaul. So let's dive right in. At the show, we announced a new pair of access points. So these are our entry-level access points, the CW9172 I and H, and that is the internal Omni and the hospitality or wall plate version. These are direct replacements for the 9162, that level of access point. Get into some details. I've highlighted the differences between the two in green on this slide. The coolest thing about these APs to me is that they are fully functional. The radios are fully functional on 30 watts of power. So there are some things that shut off. We turn off the USB port on the I. We don't allow PoE out on the H because there's no more PoE to spare, but on 30 watts, radio is fully functional. They are very capable APs for their size. You can see they are each 6 spatial streams, and the CW9172I, you can select whether you want tri-band or a more robust dual band AP. So it can be 2x2 on all 3 bands, or it can be 2x2 on 2.4 and 4x4 on 5 gigahertz. You have that option. Doesn't have that option on the hospitality AP. So to show you a bit more detail on the power and what shuts off if you draw the power down, I've created a couple charts. Again, you can see at the PoE plus level, the radios are the exact same as the UPoE level. So you're able to get full radio functionality. And then it shows the various things, states things as we draw the power back, what shuts off or degrades. Of course, these APs use our global use AP operation technology, or process, I should say, that we introduced with Wi-Fi 7. We also call it Guapo. And what this is yes, naturally. The APs are handsome. So these are single PID devices. We don't have a SKU for Europe and a SKU for United States, or a SKU for Meraki mode and a SKU for Catalyst or controller-based mode. One SKU for all the things. And I will dive into a little bit about what that looks like. So because we did one SKU, there's a process that needs to happen when you power these things on the first time to determine what the heck they are. What country am I in? What should I be? Am I cloud-based? Am I controller-based? And that process takes a little bit of time to go through the first boot only. Once the first boot is complete, it stays in that mode until you reset it or change it. There's no country code configured by default. It derives that automatically through a whole number of ways, including GPS and neighboring access points, cloud connectivity, et cetera. There are, of course, ways to deal with that. If you don't have, you're completely air gapped, you can absolutely take care of it, but most customers will do it automatically. This is what the process, yeah, go ahead.
So if you were, for example, wanting to deploy this at a remote office, you would recommend that you ship it to yourself, centrally configure it, and then ship it to the team, or would it be, could you remotely?
The best part about it is you have the option to do either.
Oh.
You could stage it and then clear the country code and ship it to the remote location in another country, and it will rediscover the country code but save the configuration when it gets there.
Okay.
Or you could ship it over there and configure the whole thing. You could use plug and play. The beauty of it is it will figure itself out regardless. You don't generally want to leave a country code configured and ship it to another country, but we let you just reset only the country code, or both. You can reset the config as well, of course.
Cool.
So this is what the process looks like, just real briefly. You may have seen this slide before, but when it boots, it needs to determine whether it is Meraki or cloud-based versus controller-based. And that process starts by checking the Meraki cloud, looking for whether it's been claimed in a network, things like that. If it doesn't see itself in the cloud, it will then start to discover controllers via the existing means you're familiar with for controller-based APs. There's a way to shortcut this as well to speed things up, but you get that part, it figures out its country code, it figures out its mode. Day one operation, it stays that way. Every time you reboot it, it doesn't do that discovery again. It remembers that it has this country code and this mode. You can convert between the two. You no longer have to open a TAC case to convert from Meraki back to Catalyst. You can do it either way, as many times as you want. And then, of course, you can factory reset it. And if you factory reset it, it goes back to the beginning and starts that discovery process again. So I just want to reiterate, if you do nothing, treat it just like an older access point, it will function. It will get there. It just takes longer. It might take 15 minutes the first time it boots to figure all this stuff out, and then it will proceed with the normal boot. But you can use some DHCP option 43 values, new values, to kick it one way or the other, whether you want it to be controller or cloud-based. The options are there. I also want to cover some stress test results. My friend Jim and I went to Richfield, Ohio, and ran some tests with Wi-Fi 7 to see if we could break MLO, basically. We wanted to see what happened when we really loaded some APs down, and if you did things poorly or incorrectly, or if your environment dictates that you have some channel overlap and that sort of thing. So we wanted to see how bad we could break it. This is the overlay of the overview of the test layout. We had 20 Windows laptops in 4 groups of 5, and we were pushing traffic to them with IX Chariot, and each of them received 2 flows, and I'll give you the aggregate flow data here in a second. We were pushing them as hard as we could. These were dual band clients, or tri-band, but using 2 bands, 5 and 6 gigahertz clients. And the APs, of course, were 5 and 6 gigahertz as well. They were placed about 15 meters apart through a wall, kind of a typical spacing, and then we also spaced the clients out. You can see the blue rectangles on the map are the tables we had the laptops on. So the first test is all radios on separate channels, basically the correct way to deploy Wi-Fi, nothing overlapping. We got about 2.8 gig of average overall throughput. That's the complete amount to all clients. Now, you might think that seems pretty low for 20 clients when you're at Wi-Fi 7, but we were literally doing bidirectional full throttle traffic to 20 clients at once on 2 APs. I think that's a pretty impressive number considering what was going on. I mean, everything screaming at each other at the same time in both directions. Latency stayed pretty low, around 65 milliseconds. Looked really good. So then we started to break things in various ways. We put the 5 gigahertz radios on the same channel with the same primaries. Right, not ideal, right? You can see that the throughput didn't change a whole lot. The latency just about doubled, but the throughput is still pretty good. Most of the data is happening on 6 gigahertz in this demo. That's clients seem to prefer 6 gigahertz for high throughput stuff. So it didn't affect it a whole lot. So we decided to keep breaking stuff. Then we flipped the primary. So same channel, but on different primaries. So the APs can't really see each other. They can't coordinate back off anything. They're just stepping on each other. That hurt it really bad. You can see the throughput went down to 1.2 gig and almost 400 milliseconds of latency. So big difference there when you have a full conflict on 5 gig. Then we decided to play with the 6 gigahertz side. So we put 5 gigahertz back on separate channels the way it should be, and we split 6 gigahertz. You can see the throughput came up a little bit, latency got a little bit better, but it's still pretty rough. And that's interesting because 5 gigahertz, when we put them on the same channel, it was still pretty good. So thinking maybe management traffic might be on one band versus data on the other, that sort of thing. Every client behaves a little bit differently, but this is just some food for thought was mimicking an actual deployment. So lastly, we put 5 gig on separate channels again, and we misaligned the 6 gig primary. So this is the worst case scenario for 6 gigahertz, same channel, but different primaries. Throughput came up a little bit, 1.6, but the latency got even worse, almost 600 milliseconds of latency. So just wanted to share some scenarios. It's not often that any of us are able to really sit down and kind of lab test and compare results from one to another with consistent surroundings. So it was fun. Wanted to make sure to show it. Now I want to talk about AnyLocate. And I've spoke about this before at field days, but I want to give you kind of a high level of what it is and talk about the cool stuff we're doing. So AnyLocate is an umbrella term for our advanced location technologies as well as the AP auto-locate function that we have. And what it boils down to is the accuracy of AP positions on maps is the fundamental basis for all things location services. If your APs aren't placed properly on maps, you don't get good location accuracy, period. Nothing will fix your accuracy if your APs are not well placed. So the AP auto-locate function will auto-place APs on maps. We've been doing this for a couple of years now. It works pretty well. We've been doing it with fine timing measurement on the Wi-Fi radios, and it measures the inter-AP distance with FTM between the APs and then computes kind of a matrix of locations of APs.
And the heat map.
I'm sorry?
And the heat map also.
Yeah, the heat map can benefit from it as well. Primarily, we're trying to figure out exactly where the APs are. If you rely on heat maps to show your RF coverage, they'll of course be more accurate as well. We also offer this same technology for client location, so you can do FTM with clients. But we wanted to step it up, take it to the next level with ultra wideband. So we have ultra wideband radios integrated into our 9176 and our 9178, and that's my feeble attempt at an X-ray animation. So you may not be familiar with ultra wideband because it has nothing to do with Wi-Fi, but it's a short range, high frequency technology that exists in iPhones and other Android phones for searching for tags and things. You've probably seen it. It's very, very accurate. Sub-meter accuracy, way less than sub-meter in a lot of cases. And we're integrating it to kind of make the existing use cases better and explore new use cases as well. So the first use case is that it enhances AP auto-locate that we just talked about. We're offering this technology between APs. So we're combining the results from FTM, which were already pretty good, and also using UWB to get that sub-meter accuracy. So it has made a substantial improvement in the location accuracy of the APs. There's that area of certainty or uncertainty that you see sometimes when you're looking at the GPS on your phone. If you're in a basement, it'll be very big, shrink down. That area gets smaller with these technologies combined. This is an example of what it might look like for AP accuracy with FTM alone. So these circles are not coverage areas. These are areas of certainty for the location. Pretty large circles kind of shifted around. And this is, the AP would be in the center of the circle, but I'm trying to depict the difference. This is what it looks like with ultra wideband. So much, much smaller circle, much more accurate, consistent results. We're seeing about 95% results better than 2 meters accuracy and quite a bit better than 1 meter accuracy as well. And that's a big improvement from FTM. And to pull me offline, I'd be happy to share some more details on it. I also want to do a bit of a public service announcement because I get this question a lot for our AP auto-locate. You can absolutely preview before committing. You do not have to accept the results. So don't be scared to run AP auto-locate. It isn't going to ruin your existing map or AP locations. You can simply run it and it will preview the data, and then you can say, yes, I'll save it, or cancel it. And this is in all 3 platforms. So it's in beta right now in Catalyst Center, but it's public on Meraki as well as Spaces. So all 3 give you the ability to preview before commit. So don't be afraid to test it out. These are the platforms and access points that are supported. I won't read through all of them, but it's supported on a lot of APs going back a few generations. And like I mentioned, all of our platforms. If you want to test it on Catalyst Center, please reach out to me and I can turn it on. It's a controlled beta at the moment, but I can absolutely turn it on for anyone that wants to test it. So the last topic I want to talk about is UWB, or ultra reliable wireless backhaul. Have you ever wished that wireless could just be better, essentially? Lower latency, less loss during roaming, more resilient, more redundant, etc. You can't do that with Wi-Fi alone today. We're working on it, but can't get there completely with just Wi-Fi. There are some fundamental challenges with the way that Wi-Fi works. For example, the break before make nature of the roam. It has to disconnect from the current AP before it connects to the next AP. You're going to get packet loss in that scenario, just naturally. That's how it works. Depending on what you're doing, that may or may not affect the application, but you'll get some packet loss. And you can only connect to one AP at a time. Of course, that's what we're used to. So that means can't really be redundant. Now, MLO helps with that. You can do 2 connections or 3 connections to the same AP potentially. Different clients handle that differently, but it's not a true redundant solution. Now, some of the upcoming wireless standards may address this. When? No, probably not the initial release. Things are improving, but at a slower rate. And these are real problems that need to be solved today, and we can solve them. So we solve them with ultra-reliable wireless backhaul, which has been around for a while now. We've 5 years since we acquired Fluid Mesh. The technology has been there, but it has always been kind of a separate thing. It supports point-to-point, supports point-to-point, point-to-multipoint, mesh, mobile, all the things that you would expect for wireless backhaul to work. And clients connect through a Cisco AP. So think of it like on a fork truck in a warehouse or an AGV in a manufacturing facility. There'd be like a 9165 or some small Cisco AP on that, acting as sort of a workgroup bridge, with familiar terms to us. It would connect to UWB. And the primary benefits of UWB over Wi-Fi are that it is zero loss roaming, true zero loss roaming, no packets lost. The latency is better because the back end is different. This is non-Wi-Fi. It operates on 802.11.5, but the whole communication is non-Wi-Fi. And multipath allows a device to connect to multiple APs at the same time redundantly and send the same traffic 2 places, and it gets joined on the back end. So if anything fails, you don't lose a frame. Now, that's not the way it's typically deployed, but if you have that need, it absolutely supports it. You can even have 2 APs on the vehicle connecting to 2 APs on the infrastructure, completely redundant from end to end, separate power, everything, if you want to.
How many paths are supported?
2.
2 paths, yeah.
Yeah, 2 paths. So up until now, this has always been a separate infrastructure. Like I mentioned, you had to deploy different APs in this mode. It's been completely separate. Some of the use cases are manufacturing AGVs, like I mentioned, mining, real fast moving things like high-speed trains, et cetera. And a typical design would have been 9167s on the ceiling and 9165s on the vehicles. That's kind of the most common way to deploy it. And you're probably thinking, why are we talking about this if we've been doing it for 5 years? And the reason is because we now offer it integrated into our APs at the same time as Wi-Fi. So you can choose one radio and put it in UWB mode and have the rest of them doing Wi-Fi. So if you have a dual 5 gig AP, put one of the 5 gigs in curb, one of the 5 in Wi-Fi, and you lose nothing on the Wi-Fi side. You don't need to dual boot. It's the same image for both. In the WLC, all the same. And it can be enabled per radio or via our radio profile in the 9800. And even the vehicle end of it is managed in the WLC. That's an ask that some of our workgroup bridge customers have had for a decade at this point, is that they want that mobile end to be manageable. And now it is in the WLC and other platforms to come. We are still offering the traditional way if you want to deploy this without a WLC or without the rest of the enterprise Wi-Fi infrastructure. But the cool thing we're talking about is joining it today. And this is an example of what it might look like on an AP. Split up the radios, one of the 5s with UWB and one with Wi-Fi. So you can service Wi-Fi clients and curb clients or curb devices at the same time. These are the APs we are planning to support. This may change, but this is the current planned list of supporting this mid-ish of this year. There's a lot of APs on this list. Again, just like with the AP AutoLocate, we went back quite a ways, a few generations of APs to support this. And there's a wide breadth of access points as well, different styles, different use case APs. I want to show you a video demo, a short video demo of what this technology can do. This is the demo environment. I won't go through it in detail, but we have basically a vehicle with 2 9165s on it. One of them is connected via Wi-Fi and one of them is connected via UWB. Those 9165s have Raspberry Pis behind them that are generating traffic. We did some stuff in Python, made a UDP traffic flow scenario so that we could very accurately show packet loss, latency, et cetera. They're connecting to 9178s on the ceiling and back to a WLC and a 9167 as the traffic concentrator for the URWB. Pretty standard lab setup, but let's get to the video. So the way that we are instrumenting this, of course, I love Grafana, you guys know, so I threw some stats in Grafana. The left half of this is URWB, the right half is Wi-Fi. And we've got on the top chart the latency, both immediate and average. And then on the bottom chart, we have jitter, the difference in latency from the last frame, as well as packet loss. And this is live data. When I start the video, you'll see that it's changing. And then along the top, I have some tiles that identify the state or the health of things. In focus on the packet loss one, because that's what is going to be interesting for this time through. And then we've got some stats in the middle center at the top there. That's a 3-minute comparison showing the health of the connections between each other. So let me start with the video. That's the hallway 9178 access point. And that's my buddy, Chris Williams, that is pushing a vehicle around in our office. We've got URWB on one side and Wi-Fi on the other. So moving along, it's going to roam here shortly. If you pay attention to where it says hallway CW9178 on both sides, that's the currently connected access point. And that's going to change real soon for both of them. And on the left side for curb, just roamed, nothing changed. No packet loss, latency didn't change. It was like it never happened. It roamed between. The right side also is roaming now. You'll see the AP change momentarily, but it lost 51 packets. Now these packets are UDP frames being sent every 50 milliseconds, so it's an extreme test. You wouldn't see 51 pings drop via a simple Wi-Fi roam, but we're trying to show you basically how long the outage is as it roams. And this is 11R, by the way. This is not artificially trying to make Wi-Fi look worse. We gave it the best scenario on both sides. So we keep moving back and forth. You see another roam there, more packet loss on Wi-Fi, nothing on URWB. This continues on for a bit back and forth, and trust me, there's never any packet loss on the URWB side. Yeah, it's impressive to see the difference between the two when you're really looking at something like a streaming video or anything where data is sensitive to packet loss. So that is all I had. I'm going to turn it over to Min-Se Kim. He's going to dive into some awesome things that we've been working on.
All right.
Here you go, Min-Se. Thank you.
Thank you, Dave. I'm hoping to have that Wi-Fi as my home Wi-Fi. Isn't that great? Yeah. So today I brought a couple of AI iterations that we have done lately from the last Tech Field Day to February. And then we made a couple of amazing progression, such as the generic availability of intelligent capture. I've been presenting a couple of times, but it was all about beta, lab, POC. And now it's fully functional, available to everybody. I'll talk about that. We'll also talk about some of the monitoring and visibility improvement for the infrastructure. That's something that the Meraki user has not been fully appreciated on the some of the abstraction that we have done in the Meraki dashboard. Sometimes, like if you don't see a light, then everything is green, right? So we decided to expose everything, what's coming under the hood, under the scene. So now you have a full transparency of the device monitoring. In this case, infrastructure. Third case that I want to cover is the AI-RRM, what happened from past, especially from the efficacy of the AI-RRM, which hasn't been covered in the prior topic. So let's start from the intelligent capture. So what it is and what we're trying to do. So let's assume some of the day-to-day operation. And we all probably know that only time that the NetAdmin is trying to take a look on the Wi-Fi dashboard is some of the VP and the VIPs are having a bad day in the morning. So it always reported in the delayed fashion, hey, I have some bad things happen. My WebEx, my Zoom, my meeting with my board members, investor went south. Hey, check out what's happened in Amsterdam, right? So then the guy sitting in the maybe France or other theater, other continent found that there is a no expert in country level. So, okay, what to do next, right? Okay, and looks like this is not the first time. Happened few times, but I really couldn't do much properly. And then I still have to figure it out whether it's a network issue or client issue. Basic 101 of the Wi-Fi troubleshooting. So let's get some packet capture, right? This is a natural progression of the next step. So to get a packet capture, what we have to do? Let's start from the, let's just bring my old LPCAP card and try to get some, hook up my Wireshark. And then I suddenly bump into a couple of interesting challenges here, right? First of all, I need to know which AP was serving that client and what was the channel for that part. I need to know which specific 5 gig channel they have to looking into. And obviously, we are living in the high density world. There's a multiple AP, multiple channel. So they're okay, yeah, probably we have to use a channel bonding up to 3, then realize that these packets are all encrypted. I mean, problem was my WebEx meeting problem. It wasn't really clear that it was a connectivity problem or application problem, but data is encrypted anyway, so probably have to take the multiple packet capture from the wired and wireless, right? And then client might be moved between the 2.5 because of that we enable it, especially with the 6 gig, right? 5 gig, 2.4, 5, 6, MLO, right? Multi-band PCAP, multi-band troubleshooting is a new norm with the Wi-Fi 7. How we are going to troubleshoot that? How are we going to take a packet capture, right? It's super challenging. At the moment, with a third-party tool, we probably need to figure out what to do, right? What about the using AP as a packet capture devices? Given that this is remote environment, I don't have anyone on site with a packet capture tool. So let's convert AP into sleep-on mode, Prometheus mode, which is pretty much what we can do today. But if we do that, what we found is it's all about RX. I can't really correlate with a specific failure event with a PCAP. Probably I need to use my own brain to make some chronological correlation. I need some expert to look at that, right? What about the packet itself? Can you get every packet? Sometimes it doesn't, right? Sleep-on mode AP is sitting on the other side of a corner while the failure is happening the other end, right? So there's a distance and the limitation, and sometimes I need to get the both wired and wireless, which is impossible to get the wired because of the packet failure happened on the one AP, while the Prometheus mode AP is sitting on the other side. We can't get the wired and wireless packet capture either. What about the dashboard? Looks like many vendors are kind of approaching, hey, I have this amazing dashboard tool that you can easily trigger and packet captures and do that lot of things. Looks like a great idea. But what has been the existing tools experience that the network vendors offered? There was some debate about whether we should store the PCAP historically or not, especially important in Europe. All these privacy matter, but that's probably more compliance, not a real technology limit. But sometimes I do not get the full packet because of the packet capture through the dashboard. It takes a lot of back-end complexity. Sometimes the many vendors and implementation do not have a full data. So in the Cisco cases, when we designed the internet capture first in the Catalyst Center 4 or 5 years ago, we had to build a special mode called the full data packet capture. Because the regular mode, we won't be able to get the full data packet. And sometimes packet comes in a different order. If I get the management frame, data frame, let's say that you have the block request and PA in out of order fashion. Entire backup is no use, right? You have to get the proper timestamp. And this is a little bit interesting topic. I will explain later why this become one of the most commonly discovered scenario, especially when you try to capture from the dashboard. Size limit, Wi-Fi 7, MRO. At least this one seems to be the most advanced topic because of a lot of vendors try to monetize by adding additional functionality, but it doesn't come without their own caveat. So let's come back with the traditional scenario. So this is a traditional inline packet capture. So inline means that we are capturing from the data plane of the AP, which is great. We can get all the data decrypted, nice, looks like it's working fine. But there's one caveat. Because of the in the design and architecture of AP, there's a 2 split head. There's a data plane side, main OS. You can imagine the host APD, WPS applicant, those things are all sit on here. But there is a Wi-Fi modem, does all this low layer operation. Beacon, probing, control frame, all happen generated by modem. It never go back to data plane. So if you try to take a packet capture, often that you miss these whole pieces. And then you ended up, you only got partial packet capture. And this is a big problem in the Wi-Fi 7 because of the more and more devices are relying on the control frame, action frame. Imagine that you are troubleshooting 802.11u, which is using ANQP action frame, which all entirely generated from the AP modem, not on the main OS. So all these problems comes into the way that our packet capture has been partially useful, but not fully functional. What about the Prometheus mode? Prometheus mode seems like an answer for many cases because I don't need to worry about like a missing packet, partial packet, but at the same time, it's just RX only. There's no TX. So I only can approach it from the third-party view. It's not too different from the just having an AirPcap adapter on site. But other than that, I still have to deal with all the problem that I had in the third-party toolway. So how we can solve this problem? How can we move forward, right? That's why the intelligent capture comes in. I think I've shown this the slide. So I think that really the visualization, let's move on. I did that. The key point is the internal architecture. How we made that happen. How Cisco was able to solve all this problem. To be honest, in the couple of pages that when I list out the challenges, it was only partial. It took me 10 minutes to list down all the problems that we have because there's so many limitations that we have in today's packet capture system. So what we have done at this time is we designed the entire packet capture from ground up at the AP and hardware level. So first of all, when you get the packet capture, the Wi-Fi modem itself always replicate the exact outbound, the over-the-air traffic to the packet capture module. So it happens all the time. So every time we take a packet capture, that's why we are able to get the probing and the control frame and the beaconing all the time because we are replicating all the time. And then, of course, the data comes in order. And now the interesting part is how we can make this scalable because the simply amount of the management frame and all the data traffic can be overwhelmed. That's why we are able to increase or design the special buffer. So Cisco's intelligent capture buffer, what's unique about it is we have the n number of the link buffer, n being equal to client count. And how many clients we can support for single AP? 1,200. A humongous number of concurrent client support. And then we have a 1,200 ring buffer. So thanks to new AP, Wi-Fi 6E and 7, we just able to get so much of hardware capacity. And now even the intelligent functionality is fully leveraging these inherent hardware strengths into the product and put together as a solution. And what it does as an end result, I can get a full packet anytime, every time. And we don't even need to do any of the prep work because the system will always automatically capture, store, and upload to the cloud. So there are a lot more exciting architecture from the behind the scene in the cloud layer, but I didn't go there too much because it might be most interesting, but I probably wouldn't cover any second topic. So I'll just stop that. And then this is what we have added from the last time. We didn't show the packet analyzer back in the last time. So now we have a packet analyzer embedded, extended with a Wi-Fi protocol. So our approach that we took was because we are gathering the millions and millions of files every day, we were able to kind of sorting top 10 failure cases. And in each top 10 cases, we were able to build a special parser. And the user was able to easily identify which packet is the source of the problem, what cause and why it caused. Right. And all these things are available from dashboard with just one click.
I have a question on the previous slide.
Yep.
You're copying a Wireshark effectively to the cloud. That could have privacy data from customers that didn't agree to that.
Yes.
That's a potential data leak of sensitive data.
Yes. So that's why this functionality when we ship it in disabled fashion. So there was a customer's comment on the community page, American community, that why you guys enable it by default. If this is so useful, you shouldn't enable the disable by default. That was the one of concern. I need to have an explicit end user consent to enable it. And then another part is we are developing the new mechanism of store the packet in their own local private S3 bucket, what we call the BYOB, bring your own bucket. So bring your own bucket, I think the same question was made by the Sam the other day. We haven't built that yet, but that's a part of the current R32 plan. And probably this summer, next Tech Field Day, we'll be able to update the BYOB plan. Yep, thank you. All right, let's get into a quick demo.
I have one last question for the last thing. Let's say I have a problem with roaming and clients moving. So I could fire this up, not for a single AP, I could fire this up for the, let's say, whole Cisco Live, yeah?
Absolutely, whole Cisco.
All the APs. Do we have then a comparison function as well, where I can, let's say, follow the client moving from different points?
So right now, when client fail to roam, we actually capture packet from 2 different AP. And then the first AP roamed from AP, send the packet to their roam to AP. So when the packet gets sent to a cloud, it just sent as a one packet. So you don't need to kind of stitch the 2 different PCAP and try to, okay, whether from which AP to which AP, you don't need to worry about it. Single PCAP failures with a roaming failure, we'll have both.
Okay.
Yeah, and according to that, because this is troubleshooting when you have Wi-Fi problems. And I want to go a step before that to show more client analytics out of the node itself. Is there an upgrade?
Yep, so that's what we call as a single client troubleshooting workflow, which are actively working on. In fact, I have some slide, maybe the Tony is a PM for that project, single client experiences. So Tony will be able to show it next time, next Tech Field Day, which actually combine the wireless and wired all put together in the historical manner. So what I'm saying is, if you look at the traditional timeline of a Meraki, right, it only shows one aspect, which is a wireless timeline. It doesn't show any wired timeline. It doesn't show me any correlation with switch capabilities or WAN failures or application problem. And I have to have it with the contextual manner in the chronological order, right? I need to go back to yesterday, go back to last week and see what happened on that particular moment with the switch and application. That's all putting together, and that will replace the current 360 pages of the Meraki, and that will be brand new. Yes, Tony? No, 5 minutes. Okay.
Plus, I mean, you're doing a great job with great state-of-the-art access points and hardware, but clients rule the Wi-Fi world, right?
Correct.
And troubleshooting Wi-Fi is going from down to top.
Yep.
So you need more information, more client analytics to do better troubleshooting out of taking a
100%. 100%. I think you are setting the stages for me. In fact, Cisco is the only vendor who is gathering, or actually getting, because they are sending us the proprietary information of the client connection failure from their supplicant directly over the L2 from their each modem, each client to the Cisco AP. The vendor who agreed to sending and actually sending to us right now is Apple. All the Apple devices, iOS, Mac, iPad, everything, every Samsung devices, all the A series, I mean what's the series, right? S series, they're all sending the proprietary supplicant error code to a Cisco AP, and the Zebra, we're sending Intel, they're sending it. The only thing is, hey, why you are not demoing us? We actually have it already in the DNA center. I probably would have shown it this time, but it has been available for quite some time.
Yeah, maybe more extra information out of the client before we go troubleshooting and capture.
Yeah, absolutely. I took a note, and actually that's indeed one of the projects I'm working on. So looking forward to meet you again next time.
Hopefully.
Yep. That's what we call the client analytic project, and there's some big thing is actually happening right now. All right, Temo, I got only 5 minutes, so let me go real quick, because I have a lot to cover today. Let's get into intelligent capture here. So a typical client overview pages, and I know that how to get into detail. There's some failures going on, authentication failures. So let's get into let's say the temporary refusal, which is super difficult to troubleshoot it in the most of cases, right? And then in such cases, a device had been disconnected by AP a few times, and let's find out what happened. Go to timeline and just filter with packet capture. Yeah, well, you have a packet, right? It said that the client failed during the association. And then here, just click the view packet capture. Then now you have a familiar Wireshark view. And then it also pre-filtered with colored with the proper, the filtering, right? We have if messagings going on. So it seems like overall looking okay, but there is a deauthentication happened from the client. From the AP, and the AP was not able to handle this client connection properly. So then that's why that we have a packet captures enabled with a timeline. So now we can work with the device maker to continue further defer that why we are getting these messages. But in these cases, it's happened once out of the thousands of authentication cases, but probably not so much of the super duper amazing. But when you have a 3 second of disconnection for certain unplanned time, now you have a full data to looking into and deep down delve into further. That's the key idea here. Let me get into our next topic here. I know that I'm kind of rushing here, but a lot to cover. I want to start with the basic. Sometimes the Cisco saying that the simplicity is a really rule, but no, I need to have every single bit of information because that's the whole point of assurance, right? And 99% of the time, I don't need to look at this. But when things go south, when AP suddenly got rebooted, I need to know why AP got rebooted. How was was there any memory leak happen? Was there any CPU hogging process happen? What is my device? The trending view of rebooting and uptime condition. Device uptime is a #1 requested feature by every customer, and we are providing an additional context of the reboot reason. So none of this has been available from Meraki the past few years, and we realized that every enterprise requires this type of information as the most basic foundational info, and now everything is available. Customer can build their own dashboard using the API. Meraki Grafana support that. Let me cover one last topic because my time is up. I will just cover one part. We got a lot of these things going on, but I will skip that. I'll just want to cover one thing, the whole AI-RRM story. We've been heard enough, right? Okay, it's good. So what? How much is good? How you can convince me, right? All these things look at slideware. So what we have done was building the AI-RRM into the measurable, the statistic. Any success has to be measurable, right? So what is my Wi-Fi performance look like? How's my Wi-Fi score look like? Which was done by Javier in 2018. We use the same algorithm. Now we can see a before-afterward view of how my network behave. How's my channel changes? Channel changes often become a big source of the unplanned disconnection. And now the channel changes being measured, monitored, and now see that how channel changes contained after AI-RRM. What is my core channel interference, which is #1 reason of the bad Wi-Fi. And now I can see my core channel interference trend before afterward. Not only that, we can compare it with global fashion. So this actually measured with the peer with a very cherry pick. It's not done by the industry. We are cherry-picked by network density. We have a metric called the network density metric, so NDM, and we took the same NDM, and based on the similarly distributed AP, we know that how's my network behave compared to the similarly dense AP in the same tri metric.
It's all about RF.
Yes.
But these are RRM insights. What about ARM insights? ARM. Adaptive radio metric.
Adaptive radio metric. So we are working on building the RF health metric as a separate dashboard. And then right now, RF health dashboard is scheduled in the coming months, not this time. So stay tuned and we'll be able to update that on the next Tech Field Day update.